So let me ask you guys a quick question. When we are multiplying with exponents, the rule is that we add them. So multiply and add go together. So what do you think divide goes with? If adding and multiplying go together, what did dividing go with? Add and multiply, divide and subtract. Yes, yes.
I thought you said
yes, I'm sorry. So I may have actually, I don't know. But anyway, subtracting and dividing go together. So let me show you what I'm talking about. Let's kind of write out a few of them, and then we'll kind of come up with a rule on our own, dividing exponents. Okay, that's kind of what we're doing today, is dividing exponents. All right, so let's look at if I have x to the third over x. Okay, x to the third means x times x times x. And it's over an x. What happens when you have the same thing in the top of a fraction as you do in the bottom of a fraction? What can you do to those two things? Think about it like this. What is 5 divided by 5?
1.
What is 6 divided by 6?
1.
What is x divided by x?
X. Or no, 1.
It's got to be 1. It's the same number. We don't know what x is, but we know that whatever number it is, it's the same number on bottom, right? So they're going to cancel out to a 1. So what happens is these cancel out. So what are you left with? X times x, well that would be x to the second power. But let's look at the rule. The rule we think should be subtract. This is an exponent of 1. So what is 3 minus 1? Is it 2? Yeah. Okay. So let's do another problem. What happens if I have x to the 5th, y to the 6th over x to the 2nd, y to the 4th? Well, I don't want to write all that out, do you? No. So here's what I'm thinking. If I've got 5 minus 2, that should leave me with 3 of them, right? And 6 minus 4 should leave me with 2. That should be the answer. Now, for your benefit, I'm going to write it out right now. X to the 5th, there'll be 5 x's. Y to the 6th, there'll be 6 y's. On bottom, there'll be 2 x's and 4 y's. And when I cancel them all out, I'm left with x to the 3rd power, y to the 2nd power. So the rule does work. The rule does work. Okay. But here's the problem with this. What happens when I have more on bottom than I do on top? What's x to the 6th over, let's not do that high because I'm going to write it out. Let's do x to the 5th over x to the 7th. All right, well, let's write it out. X to the 5th means how many x's are on the top? X to the 7th means there's 7 x's on bottom being multiplied. 1, 2, 3, 4, 5, 6, 7. When I cancel all these out, what am I left with? What's on top that didn't cancel? Everything canceled on top, didn't it? They're all gone. They canceled to 1s, remember? So 1 times 1 times 1. Well, 1 times anything is just that number, right? So it's 1. It all cancels. When it all cancels, you put a 1 there on multiplying the bottom. All right, so right here, what are you left with on the bottom of this fraction?
2.
X times x. There's 2 x's being multiplied, so it would be x to the 2nd power. Okay, well, let's follow our rule. We see that this should be the answer, but let's follow our rule and subtract our exponents. What is 5 minus 7?
2.
Close. Very close. Are there more positives or more negatives? There's more negatives. The 7 is bigger and it's a minus, right? So it's not 2, but negative 2. Well, how in the world can we have a negative exponent? This is how. When what's left over, what the x's or the y's or the variables that don't cancel out, when they're left over in the bottom of the fraction, okay, it would actually give you a negative number there. A negative exponent, I'm sorry, a negative exponent, okay? So these two things, I'm telling you that these two things are equal to each other. 1 over x squared and x to the negative 2. So a bunch of mathematicians got together and decided we can't leave any exponent as a negative because it's weird, right? Do you agree it's weird? I don't like it either. So we're not going to leave any exponents as negative. What we're going to do is we're going to change them. So if we have a negative exponent, we're going to move it. So let me show you what I'm talking about here. If I have x to the negative 3 over x. Okay, before I try to do anything, I can do the rule here. Okay, I can do the rule. If I follow the rule, a negative 3 and a 1, a negative 3 minus 1 is a negative 4. But I can't leave my exponent as negative, so I gotta flip it to the bottom of the fraction. So it becomes 1 over x to the 4th power. But I'll be honest with you, this way tends to confuse a lot of people. Here's why. Because y'all stink at remembering signs. In general, right? Negative 3 minus 1. Somebody's going to write negative 3 plus 1 instead of minus 1. Somebody's going to write 3 minus 1 and write 2. I mean, y'all stink sometimes with your integers, your positives and negatives. So I tried to come up with another little way to teach this. What do you do when there's a negative number, okay? A negative exponent, not a negative number, a negative exponent. So here's the way I teach this problem. When I come to a problem and it has a negative exponent, the first thing I'm gonna do is fix it. Here's how I fix it. I circle it wherever it is and I move it. If it's negative in the top of the fraction, it means the leftovers should have been in the bottom. Okay, and what I mean by leftovers are these. Okay, these should have been in the bottom, but I had tried to write it in the top of the fraction, so it gave me a negative exponent. Well, when I move it, it just becomes positive. You don't have to do anything to it except just make it positive. So if it's negative in the top of the fraction, it means it should have been in the bottom. So I write in the bottom and fix the negative. If it's negative in the bottom of the fraction, I move it to the top. It means they wrote it in the wrong place. That's what the negative exponent means, okay? So when I see this problem, I think, uh-oh, this needs to go downstairs. So I'm going to move it down. So I've got an x to the 3rd, and I already had an x down there. And when you move it and it's all gone, this is like dividing, it kind of cancels out. It cancels to a 1 on top. Okay? So if you remember what I had written down here was 1 over x to the 4th. Well, what do I have here? 1 over, if I've got 3 x's and another x down there, how many x's are now in the bottom of that fraction? 4. So I have x to the 4th power. 1 over x to the 4th power. Okay? So let's do another one. Let's make this a little bit more complicated. X to the negative 4, y to the 3rd, z to the negative 2, over x to the negative 6, y to the 8, z to the negative 4th. That took it up a whole notch, didn't it? The first thing I want to do is move anything that has a negative exponent. So what I do is I circle it and then I move it. This becomes x to the 4th on the bottom. But this x is negative in the bottom, so it comes up as x to the 6th. These are not negative exponents. Both of these are negative, so this one needs to come up, z to the 4th. This one needs to go down, z to the 2nd. Now I'm ready to decide how many are there and where are they. So if I have 6 x's on the top and 4 on the bottom, what happens there? If I have 6 x's on the top and 4 on the bottom, what happens there? We're gonna write it out this time. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. How many x's are left over that didn't cancel out? 2. And where are they? Are they in the top of the fraction or the bottom of the fraction? They're left over in the top of that fraction. So I end up with x squared in the top of the fraction. So here's the way I usually work it out, because we're not going to write it out like this every time, right? That's horrible to try to do. So here's what I think. They look like this. I've got 6 x's on top and 4 on bottom. So I'm just going to cancel them out. But when I cancel them out, think in your head for a minute. How are they going to cancel? Well, if you have 6 on top and 4 on bottom, 4 of those 6 are going to be gone. But the extra x's will be where the bigger exponent originally was. So in other words, if I've got 6 on top and 4 on bottom, they're all going to cancel out except for 2 of them, and they're going to be on the top of the fraction because that's where more of them were. So here's how I ask that, okay? How many x's are left over and where are they? 2 in the top, so x squared in the top. So now let's do our y's. If I've got 3 y's on top and 8 on bottom, 3 on top, 8 on bottom. When they cancel, how many y's are going to be left over? If you've got 3 on top and 8 across the bottom. When those 3 cancel with some on the bottom, 5, and where are they? The top or the bottom? The bottom. That's right. There it is. So y to the 5th will be on the bottom of your fraction. Now do your z's. If you have z to the 4th and z to the 2nd on bottom, when you cancel those out, how many z's are left and where are they? 2 on the top. That's right. So z squared on the top. And that would be the answer to that problem. Okay? All right, we need to do another few examples. Okay. So let's say I have a to the 10th, b to the negative 11, c to the 7th, and d to the negative 3rd over a to the 14th, b to the negative 16, c to the 8th, and d to the 4th. Okay. Same thing. If it's got a negative exponent, the first thing I'm going to do is fix the negative exponent because I don't want to deal with these negative numbers. So this one's going to come down. This one is going to go up. Those aren't negative. Those aren't negative anymore. Those are positive. This one's negative, so it needs to come down. Okay. Now let's work through each letter one at a time. Let's look at our A's. I have 10 A's on top, 4 on bottom. How many are left? And where are they? 10 on top, 14 on bottom, so you're going to have 4 left, and they're going to be in the bottom of the fraction. So A to the 4th in the bottom. All right, do your B's. You got 16 on top, 11 on bottom. 5 left over, and where are the extra B's at? Where there were 16 on top and only 11 on bottom, so the 5 extra B's have to be on top. So B to the 5th on top. Now do your C. There's 7 on top, 8 on bottom. So there's 1 extra, and it's on the bottom. That's right. C on bottom. You can put a 1 there if you want to. You don't have to. Like on the ACT, they would never put an exponent of 1 there. Okay, they would just leave it as C. But now look at our D's. Where are all the D's? Are they in the top or in the bottom? They're all already in the bottom, aren't they? So in the bottom of this fraction, I've got 4 D's, and I've got 3 more D's. So let's just simplify that. How many D's then are in the bottom? 4, 5, 6, 7. So 7 D's are in the bottom. So I'll just write it as d to the 7th in the bottom of the fraction. And that's the answer to that problem. So here's what we're doing. When we have a complicated looking division problem with negative exponents in it, right? If it has negative exponents, the first thing I do is circle the exponents and move them. So if they're negative in the bottom, they move to the top. If they're negative in the top, they move to the bottom. But I circle the negative exponents and move them. Then I just decide if they look like this, meaning they're being divided, like a to the 10th, a to the 14th, I decide where the extra exponents would be. How many are going to be left over after they cancel, and where would they be? So for instance, with the a's, there was 4 extra a's, and they were all in the bottom. Alright, and then I do the same thing with all the letters all the way through. If they look like this, I end up subtracting the exponents, but I put the leftovers where there were extra ones, okay? And then, if they look like this, either in the top or the bottom, you just simplify it. So in other words, don't write d to the 4th times d to the 3rd. Put that together in the bottom as d to the 7th, okay? Now there's one thing we haven't gone over, so let's do that very quickly. We talked about, when we were looking at this problem right here, right before this problem, I said, what is 5 divided by 5? And everybody said 1. What is 10 divided by 10? And everybody said 1. What is negative 8 divided by negative 8? 1. And then I said x divided by x is 1, but everybody was like, uh-oh, wait, I almost said the wrong answer on that one. Everybody wants to tell me that answer is x, but it's technically 1. Because whatever number x is, when I divide it by itself, it cancels out to a 1, okay? So let's follow our exponent rules here. If this is an exponent of 1 and this is an exponent of 1, what is 1 minus 1? Anything to the 0 power is 1. Because the only way you get an exponent of 0 is if you started with the same thing in the top of the fraction as you did in the bottom of the fraction. And when that happens, it means they canceled out to a 1. It was the same number. So even if I have x squared over x squared, what is 2 minus 2? 0, which means it cancels to a 1. Okay, so that would be x times x over x times x. Well, they would cancel. And it would be a 1 over 1, which is just 1. Anything to the 0 power is 1. Everybody will always write 0 there, but don't. It's not 0, it's 1. Anything to the 0 power is 1. So that means I could give you a problem that looks like this. I can have this crazy fraction with lots of positives and negative exponents. But if I do all of that, even though it's crazy, to a power of 0, what is a power to a power? You multiply. So what is any number times 0 going to be? 0. Well, anything to the 0 power is 1. So if you ever see a problem that looks like this and it has an exponent outside that 0, the answer is 1. You don't have to do anything else to it. Because it's all to a power of 0, which means it's a 1. Okay? So be careful and look for that, all right? So again, when you're multiplying with exponents, you add the exponents. So if they're beside each other, you add the exponents, right? So x squared times x to the 3rd is x to the 5th power. But when they're in a fraction, first of all, if it's a negative exponent, you want to circle it and move it. And then if they look like this, you subtract them and put the extras where there were more. Okay, where are the leftovers? If I've got 4 on top and 3 on bottom, there's an extra 1 on the top. If I've got 3 on the top and 5 on the bottom, when I cancel them out, I end up with 2 extras on the bottom. And then if they end up beside each other, you add them. Okay? So hopefully that will help you with the dividing worksheet. We'll probably spend tomorrow going over some more of these problems And we probably will end up with another worksheet on this, just in past experience. I know it usually takes 2 days before you really get the hang of these negative exponents, okay? The dividing and the negative exponents. All right, let me know if you have any questions below the video. You can leave me comments, remember, and let me know, email me or call me or whatever if you're having difficulties.